Today we are going to deal with another component of a machine design, which is crane hook, okay, which is widely used in hoisting systems, which are used for material handling, okay. So types of cross sections that are used in crane hook are triangular cross section, trapezoidal cross section, rectangular cross section, and circular cross section. Out of these four, two types of cross sections are widely used, that is triangular cross section and trapezoidal cross section. I will explain about this cross section later on, okay. First let's see what are the first let us see what are the notations of a crane hook, okay. C is called a bed diameter, okay. J is the throat diameter, throat of a hook. H is the depth of a cross section. Bi is the width of a cross section. Cross section is a part of a crane hook, okay. Ri is the radii of intradose, okay. Ro is the radii of extradose. R1 and R2 is the parameter of a cross section. Rn is the radius of a neutral axis. Rg is the radius of a centroidal axis. See, this is the C, which is bed diameter, okay. From here to here it is bed diameter, and from here to here it is throat of a hook, okay. And this is the cross section. It is a trapezoidal type cross section. From here to here it is RO, okay. From here to here RI, and H is the depth of a cross section. See, for designing of a crane hook we need 4 steps, okay. First of all, the parameters of a crane hook we need to find, then find the resultant stresses, okay, bed diameter and dimensions of a crane hook, okay. When capacity of lifting is given and tensile stress is given and we are asked to design a crane hook, okay, at that time we need to take bed diameter is equal to C and find out the resultant stresses. On the basis of resultant stresses you need to find the bed diameter, okay. Now we'll be going to understand the parameters of a crane hook, this step, okay. So bed diameter C is equal to x root of P, where P is the load and x is a constant which varies from 12 to 24, okay. Second step comes here, we need to find the throat of a hook, okay, where J is equal to 0.75 of C. Here throat of a hook depends upon the bed diameter, as the bed diameter is directly proportional to the throat diameter, okay. Which means throat diameter is 0.75 times of bed diameter, okay. It will be larger than the bed diameter, okay. Next is the depth of a cross section. Formula is 10 root of P plus C upon 10, direct substitution. Next is the width of a cross section, okay. Bi is equal to 0.65 of H. Width is higher than the depth, okay. Next is inner and outer radii. Ri is equal to 0.75 C. R0 is equal to 0.75 C plus H, okay. Next comes here is a parameter of a cross section. R1, R2, O1 and O2, okay, which is Rack's formula based substitution, okay. 0.75H, 0.125H and 0.125. These both are same, R2 and O1 and O2, okay. Find out the area of a cross section, which is half base into height. Here here formula is half into H, which is the depth of cross section, into width of a cross section, okay. So next comes here radius of centroidal axis and neutral axis, okay. it depends upon the type of a cross section of a hoop. Okay, see, this is a trapezoidal cross section. Okay, see, BI is the width of intrados and BO is the width of extrados. Okay, this is the axis of a shaft at which the hook is attached. Okay, this is the centroidal axis and it is neutral axis. Okay, this. Okay, from central axis to neutral axis it is Rn, and from central axis to the centroidal axis is Rg. Okay, and from central axis to this first part to this part it is Ri, and from central axis to end of a cross section. Okay, it is Ro. Okay, and this is the depth of a cross section. Okay, and difference between neutral axis and central axis is called eccentricity. E is equal to Rg minus Rn. Okay, so for finding the radius of a centroidal axis and neutral axis, there are formula. Okay, standard formula. Okay, which is bi upon b0 divided by 2 into h divided by bi r0 minus b0 ri upon h into log log base e into r0 by ri minus bi minus b. Here, first of all, bi comes and after it is proceeded by b0. Okay, in whole formula bi comes and bo comes afterwards. Okay, here for remembering the trick is bi br. Okay, and then bo and br means I and O, I and O and I. Okay, next comes Rg is equal to Ri plus H by 3. Okay, into Bi plus 2B0 divided by Bi minus C. Bi B0, Bi B0. Only change is there, plus minus, here 2 is added, in multiplication H and here 3. Okay, this was the for triangular trapezoidal cross section, and for the triangular cross section the formula is the same. Just substitute B0 is equal to 0 everywhere. Okay, here B0, here B0, here B0, here B0, here B0. Okay, next step is calculating the resultant stresses. Okay, so the formula is same. Resultant stresses for sigma I is equal to sigma I is equal to P upon A plus into M Hi upon AERI. Okay, and for resultant stresses at outer side, okay, sigma O is equal to P upon A minus M HO upon AERO. Okay, only the change is here. See, for inner side and outer side there is a major changes plus and minus. Okay, and only changes here is for the H and R. Okay, only H and R change. For inner side is HI RI. Okay, for outer side HO and R. Okay, so where M is equal to P into Rn. Okay, HI is equal to Rn minus Ri. Okay, H and H0 is equal to R0 minus Rn.